Okay, this morning we're going to start in with some polar coordinates. So things are going to change a little bit in terms of the way that you have come to know ordered pairs. So we're in our notes, section 6.4. So section 6.4 of your notes, and you are given this ordered pair. And you are asked to change it into rectangular coordinates. Now, what does that mean? Well, these are what we call polar coordinates. The variables are r, theta, and I'm going to explain that in a minute. Rectangular coordinates are x, y. These are the ones that you are very, very familiar with. So we're going to change from our new coordinate system to our rectangular or our more familiar coordinate system. So what does this mean? Well, this means that whatever point we're going to plot here is 2 units from the pole. That is, that point now is going to be called the pole. Over here we call it the origin. But we're going to be 2 units. This is the distance from the pole. So r is the distance from the pole. And this is the angle in standard position. Now, what does that mean? Well, you're familiar with that concept already. When we talk about standard position, we talk about measuring from here, the positive x-axis, and going this way. So we have to figure out what that angle is, and then count out 2 units from the pole, from the origin, and that will be the point we're talking about. So, 2 pi over 3, we haven't done this in a very, very long time. That's a radian measure. We need to think about what is that radian measure in degrees. Well, remember, pi is 180, divided by 3 is 60, times 2 is 120. So that angle is 120 degrees. So let's go through that again just to make sure everybody remembers. Pi is 180, divided by 3 is 60, times 2 is 120. We haven't done that in a very long time, but we did a lot of it back when we did it. So we have a 120 degree angle. So I'm going to erase some of this other stuff so I can draw my picture. And I'm going to draw a 120 degree angle. And I'm going to count out 2 units. Now in a minute we'll be doing some work on some actual graph paper, but for right now we're just counting out 2 units. So we're 2 units out, and this is 120 degrees. So this is 2 units long, and that's 120 degrees. Now, your job is to do exactly what we did in the last section when we were talking about vector components. You have to find the x and the y. Kids, you already know how to do that. You already know how to do that. To find x and y, we're going to first of all figure out what this little angle is right here. And then we're going to use sines and cosines to do that. So here we go. This little angle, let's see, that's 120. So 120 plus what would get me to the 180 line? This is the 180 line. So 120 plus what would get me to the 180 line? Well, this has to be 60. So then we're going to say cosine 60 equals x over 2. Remember, cosine equals adjacent over hypotenuse. And sine 60 equals y over 2. And then we will multiply 2 cosine 60, 2 sine 60. And that's how we'll find x and y. This is exactly what we did in the last section. I'm going to grab my calculator. So I ended up with the ordered pair 1, 1.73. Now, just like before though, we have to pay close attention to where we are. 120 brought me over into quadrant 2. So x is negative. Y is still positive, but x is negative. All right. I wanted to do this first because I want to show you how it connects exactly to what you already know how to do. But now I want to show you something a little bit new. A little bit of a shortcut here. If you have your book and you look in this section 6.4, you will see there are some important things in the section that they sort of want you to memorize. And two of the things are these right here. We'll talk about the other ones in a minute. But two of the things are right here. X equals r cosine theta, y equals r sine theta. You have been doing this all along, you guys. That you've known that the cosine equals x over r, so when you multiply the r over, that's how you get your x coordinate. I want to show you something here. If this is our r and this is our theta, and that was 120, remember. What happens if we just type, without drawing a picture, without doing any other math at all, what if we just type 2 cosine 120? And 2 sine 120. We'll do that for a minute. Do that for me real quick. And what happens? Well, what happens is you get exactly the right answer. And the best part is the negative comes in automatically. You don't have to remember to put it there. So I would suggest that going forward, if you want to find x and y, you use this right here. You don't need to draw a picture. You don't need to write any equations except this one. You just write down x equals r cosine theta and y equals r sine theta. And that will be your answer automatically. Well, that's pretty cool. Let's try the next one then with that in mind. I'm going to write this down here. X equals r cosine. You should have these written down. Put a star or something by them. Okay, so our next point is negative 3 comma 135. This is r, this is theta. And we're changing it into x comma y. We're changing it into rectangular. These are polar. These are rectangular. And we're going to talk about graphing these in just a few minutes. But right now, let's just hang on and do the conversions. So according to my formulas, I want to find x. So according to my formulas, x equals r cosine theta and y equals r sine theta. So I just go to my calculator, negative 3 cosine 135, 2.12, and negative 3 sine 135, negative 2.12. Now, if you use these formulas, You don't change any signs. You take whatever comes out on the calculator as the correct answer. So that is the correct answer. Wow, that's pretty easy. Let's try the next one. 1, 317. Okay, so this is a polar coordinate right here, 1, 317 degrees. And we're going to change that into rectangular. So x equals 1 cosine 317 and y equals 1 sine 317. .73. Negative 0.68. And that's it, guys. That's all there is to it. Incredibly easy. Put a star or something by these. We want to have those in our notes. We want to be able to use those. Okay, we have one more. This one is 4, 5 pi over 6. All right, now this one's going to be a little bit harder, but not hard for us at all, because that's a radian measure. And so we can either change our calculator to radians and leave the radian measure, or we can just change that to degrees. Here's my fear. When you start changing your calculator back and forth from degrees to radians, sometimes you forget to switch it back, and then we have all kinds of trouble. So let's just go ahead and review a little bit. Let's change that into a degree measure. So remember, pi is 180. Divided by 6 is 30. Times 5 is 150. So this is 150 degrees. So x equals, so now I'm using 150 degrees, that's my theta. Pi is 180, divided by 6 is 30, times 5 is 150. So x equals 4 cosine 150, and y equals 4 sine 150. So negative 3.46. And 2. And that's the answer to the question. Beautiful, beautiful, beautiful. So these are written down somewhere. You got those safe, highlighted, whatever. Because now we're moving on to the next section. And the next section is the same thing, only backwards. So in the next section, we are starting with the rectangular. So this is the x and the y. And we're going to find the polar. So this is the other direction now from what we just did. Now, you believe it or not, you already know how to do this. You have done this many times in the last unit. Here's what you do. Draw a picture of the point. First of all, plot the point. So over 1, up 2. And go ahead and make that little vector there, just like you're used to doing. And drop your perpendicular down to the x-axis, like you've done over and over. This is 1, this is 2. Now hold on to your hats, kids. This is r. That's the distance from the pole, which in the last unit we called the magnitude of the vector. It is now r, the distance from the pole of this point. And this is theta, which before we called the direction vector. So r and theta, if you want to think about it, they're the same as the direction angle, not the direction vector, the direction angle. So r is the magnitude and theta is the direction angle. If you want to keep it in terms of the previous unit when we were studying vectors, they are exactly the same thing. Now we're calling them r and theta. Before we called them magnitude and direction angle. You already know how to find those. To find the magnitude, we square the first one, square the second one, add them up and take the square root. So r is root 5. This distance right here is root 5. The Pythagorean theorem. Now theta, I don't know what it is, but I know that its tangent is 2 over 1. The tangent of that angle is opposite over adjacent, 2 over 1. So to find the angle, I'm going to do second tangent, 2 or 2 over 1. So second tangent 2, and I got 63.43. So while the problem looks way different than it looked in the last unit, you are doing exactly the same math. So there's the answer to the question. The radius, or the r, the distance from the pole, is root 5, and that angle in standard position right there is 63.43. Okay, that is easy. Let's do the next one. All right, so we start by plotting it. So the point is negative 3, 2. So it's going to look like that. Negative 3, 2. So left 3 up 2. Now let's make our right triangle. This is 3, this is 2. And this is r. So how do we find r? We square the first one, square the second one, add them up, and take the square root. So r is root 13. Now we need the angle. This is where things get a little bit tricky. Just like before, though. It's exactly the same as before. This is the angle. That is what goes up here. Okay, that's what we're going to put here, is this red angle right here. So first we got to find this one. Okay? Now, I got to call it something. I'll just call it A for angle. Now, what do I know about that angle? I don't want to call it theta because this is theta. This is theta. The big red one is theta. So I'm going to call this one something else. I'm going to say the tangent of A is 2/3. The tangent of this angle right here, whatever you want to call it, is 2 over 3. So that angle is second tangent 2/3. Remember, anytime that the function is hooked to the variable, you have to use second. So we're going to second tangent 2/3. And I got 33.69. So this purple angle is 33.69. Okay, so now I'm going to find the angle. Now, how do I find the red angle, the one that I want? Well, remember, all the way to here would be 180, but I didn't go all that way. So I went just to here. So it's going to be 180 minus 33.69. This is exactly what you had to do before, 146.31. To find that direction angle in vector land, when we were doing vectors, we had to make an adjustment. We could always find the one in the triangle, but then we had to adjust it to get the one that we needed. So in this case, it's going to be 180 minus 33.69. And that is the answer. Those are the polar coordinates for that set of rectangular coordinates. Okay. So now let's try the next one, which is -3, -1. And we're going to do exactly the same thing. So we'll draw a picture of it. So left 3, down 1. So I make my triangle. That's a 3 and that's a 1. Now, this is theta. That's the angle that ultimately I'm going to put up here in my ordered pair. All right, let's find R first. This is R. So we square the first one, square the second one, add them up and take the square root. So R is √10. Now I got to find my purple angle, A, right here. This little purple guy right here. I'm going to find him. The angle inside the triangle at the origin. Now we call it the pole. Well, I know that the tangent of that angle equals 1/3. Opposite over adjacent, y over x. So the angle must be second tangent 1/3. Okay, so second tangent 1/3, 18.43. So this angle right here is 18.43. Please don't put that here. What goes here is the red angle, the whole red angle. So what are we going to do to find that red angle? Well, we know from here to here is 180. And then we have to go down 18.43 more. So that angle, the big red angle, is going to be 180 plus 18.43. 180 plus 18.43. So 198.43. Just like in the last unit with the vectors, we have to make adjustments. Once we find our reference angle, the little angle inside the triangle, we usually have to make adjustments. The only time we don't is if we're in quadrant 1. If we're in any other quadrant, we're going to have to make adjustments to get the angle that we're looking for. Okay, well, we got one more in this section. And then we'll move on to something different. Now we've got 2, -4. So 2, -4. So there's my right triangle. I counted over 2 and down 4. So that's a picture of the point. Made my butterfly bow tie. Now we'll find R. So we square the first one, square the first one, square the second one, add them together and take the square root. Oh, for the first time, we got a radical that reduces. You always want to reduce your radical, just like we always have. It's nothing different. So the square root of 20 is 2√5. Square root of 20, or 2√5. So this right here, this is R. R is the same as the magnitude. R is the distance from the pole, from the origin. This distance right here. Pythagorean theorem, however you want to think about it, it's 2√5, √20. Now, theta is the big red angle. Remember, we always start right here on the positive x-axis, and we go around like that. Well, I can't find that, but I can find this one. The little angle inside the triangle at the origin. I can find him because I know his tangent is opposite over adjacent, or y over x. So the tangent of that angle is 4 over 2, or 2. I don't care if you think of it as 4 over 2 or 2, it doesn't matter. So the angle itself will be second tangent 2, or second tangent 4 over 2, whichever way you want to do it. So second tangent 2, 63.43. So this angle right here is 63.43. But that is not theta. Theta is the red angle. So how are we going to adjust it to get the red angle now? I hope you have an idea. All the way around would be 360 if we went all the way back around. But we didn't go all the way around. We stopped here, which means we had 63 more to go. So 360 minus 63.43 gives us a red angle, a theta value of 296.57. All right. Okay, so now we're on to the next section. This is problem 3, and we're actually going to plot. So now we are going to plot some points on our polar graph paper. Now, in Schoology, I did include some polar graph paper for you. So if you want to do that, you can. Now, these on our notes here, we can actually plot everything here. But for the next section, we're probably going to need some polar graph paper. So feel free to print that off or put it in Notability, whatever you want to do to get that done. So I wish I had a beautiful grid like you have. I don't. I'm going to go ahead and put some labels on here. And then you'll notice that your paper that I provided, each of these diagonal lines is 15 degrees. So they're not all marked, but that's 15, 30, 45, 60, 75, and 90. They're marked in 15 degree increments. So you'll want to keep that in mind as you graph. Okay, so the first point we're going to plot, I'm going to use different colors here. I think I have enough different colors to help you keep them straight. So the first point I'm going to plot, point A, I'll do in purple, is 2, 15. Now this is really simple, guys. Here's your 15 degree line. So you're going to count out 2 circles. So here's the first circle. Look where I'm pointing, that very first circle. Here's the second circle. So I'm going to plot it right here. That is point A. I'm going to label it point A. It is on the 15 degree line, and it's on the second circle out. Remember, this is the distance from the pole. Here's the pole. So we're going to count out 2 circles on the 15 line. And that's all there is to it. All right, so I'll do B in green. Now B is 3 pi over 2. Okay, now this is another radian measure. we'll need to change that into degrees. Our paper is in degrees. So where are we going to put that? Well, remember, pi is 180. So 180 divided by 2 is 90. So this is going to be plotted, oops, on the 3 comma 90. Okay? So 180 divided by 2, that's 90. So I get on my 90 line, which is right here, straight up, and I'm going to count out 1, 2, 3 circles. And that is point B. Isn't this easy? All right, C is 5, 2, 10. So I'll do that one in blue. So 5, 2, 10. Okay, so we want to find the 210 line. So remember, they're in increments of 15. So the 210 line, I think for you is marked. It's right here. This is the 210 line. And you're going to count out 5. So your paper has 5 circles. So out 5, 1, 2, 3, 4, 5. Out 5 would just be the very last circle out here. And that's point C. And then the last one is 4 comma 5 pi over 6. That's D. Well, just like before, it's a radian measure, so in order to use our graph paper, we're going to have to change it to degrees. So here we go. Pi is 180, divided by 6 is 30, times 5 is 150. Now, you're sitting there with a calculator. I don't think you need it for this, though. 180 divided by 6, that's 30, times 5 is 150. So now we're going to get on the 150 line, which is marked on your paper, 150, and you're going to count out 4. So my graph paper is not very good, but I'm counting out 4. 1, 2, 3, 4. So that would be right here is point B. And that's problem 3. Got them all plotted. Okay, now we're going to talk about something that's a little bit tricky. So we've got the first one all plotted. That's all good. Now we're going to plot a few more points. And now I want you to look at this next number, number 4, and I want you to notice something about it. I'm going to go ahead and erase all this. I'm going to have some work to do here to plot these. So point E is -1, 30. Now this is different because notice that's negative. And if you're awake right now, you're thinking to yourself, whoa, whoa, whoa. That's the distance. That's the circle that I count out. How in the world can that be negative? Well, it's kind of a fluky thing with polar coordinates. It can be negative, but when we plot it, we have to think of it, of course, as positive. You can't have a negative distance. So, how this works is, if the R value is a negative number, you plot the point not on 30 degrees, but on the opposite angle of 30 degrees. Now, here's what I mean by the opposite angle. Here would be 30 degrees. The opposite angle is exactly 180 degrees different. It's in the opposite direction. So instead of going 30 degrees this way, we go this way, 30 degrees this way, 30 degrees this way. So we plot it 180 degrees different. It's like instead of going forward, you go backward. So if we are going, if this is 30, and we're going 180 degrees different, then this angle would be 210. we simply add 180 to 30 degrees. So instead of plotting this point, we plot this one. The R value must be positive, so we go ahead and make it positive. But that means your angle is adjusted by 180 degrees. So we add 180 to 30 and get 210. So one more time. If you have a negative R, which we did not have in any of our problems in number 3, but now we have one in number 4. Point E has a negative R. If you have a negative R, make it positive, and then change your angle by 180 degrees. So point E, which I'll plot in red, is going to be plotted on the 210 line. And again, your paper is so much better than mine. But here's the 210 line, and here's the first circle out. So that is point E. Plotted one circle out on the 210 line. All right, now I'll do F in green. F is 2 comma negative 45. Now, there's no problem with a negative angle, guys. You know from before that positive angles are counted up. You start here, you go up. These are positive angles. Negative angles go this way. So, yes, I know that this is 345 positive, but it's also negative 15. And this is negative 30. And this is negative 45. You can name angles more than one way. If you go positive, this would be 345 degrees. But if we go negative, it's 315. It's that whole coterminal thing we talked about a long time ago. So if you have a negative angle, you just go count down, go down. Every line is 15 degrees, so this would be negative 15, negative 30, negative 45. So for point F, we count out 2 circles on the negative, on the negative 45 line. So it's right there. There's point F. On the negative 45 line, count out 2 circles. G, wait a minute, G is negative 3 comma 90. All right, so this is a problematic one. Negative angles are not a problem. You just count down. Negative R's are a problem. You can't have a negative distance. So remember how we fixed the last one? We fixed the last one by saying, okay, I'm going to make R positive. R, to plot it, R has to be positive. So we're going to make R positive. And then we have to change our angle. Do you remember how much we change it by? We change it by 180 degrees. So instead of plotting at 90, we're going to plot at 270. Because 90 plus 270 is 180. So here's 270, straight down. 3 circles out. 1, 2, 3. So there is point G. Now, when I first started talking about this, I was talking about this tells me I plot it in the opposite direction. Well, 90 is straight up. Because of the negative, we're going to plot it straight down. That's the opposite direction. To plot a point with a negative R value, you change the sign on R, make it positive, make R positive, and then change your angle by 180 degrees. And plot that one. Okay, we have one more. This is R, and it's negative. It can't be negative, guys. You have to make it positive. Now, what angle is that originally? What in the original problem, you have a pi, which is 180, right? Now, you're not going to plot it at 180, though, because that's negative. So as soon as I make that a positive 5, I have to change my angle by 180 degrees. Well, if you add 180, you get 360. But if you subtract 180, you get 0. Aren't those in the same spot? When you change your angle, kids, it doesn't matter if you add 180 or subtract 180. Think about a circle. If you go halfway around, does it matter which direction you go? No. So you're either going to add 180 or subtract 180. Either way, you're going to end up right here. That is point H. It's on the 5th circle out. It's at 0 degrees or 360 degrees, whichever way you think about it. So the original angle was 180, but it had a negative r. So I had to make the r positive, and then I had to change the angle by 180. So if you add 180, you get 360, which puts you right there. If you subtract 180, it gives you 0, which puts you right there. Doesn't matter which way you do it. This angle is left. This tells me I have to go the opposite direction, so I went right, 180 degrees. Okay. All right, next section. Now we're going to have some fun. Now we are going to sketch some really cool curves. Okay. Now, sketch and tell how many leaves and how long are the leaves. And you're looking at this thinking, what in the world? So, I'm going to go ahead and set up my polar grid. You don't have to do this. Oh, shoot. Get a little bit bigger here. And we're going to graph r equals 2 cosine 3 theta. Now, what I need for you all to do is to take your calculator, and I need you to do a couple of things. First of all, go to mode. And if you look down the row right now, you probably have FUNC highlighted. I want you to click over a couple in that row to POL. That's polar mode. So we're going to click down and click over and press enter. So we're highlighting polar, POL. So get your calculator out, press mode, and make sure you have POL highlighted. Okay? Then I want you to go to window, right here, just in the top row of buttons, right here. Go to window. And it now says theta min. And I want you to have for theta min, I want you to put 0. And for theta max, I want you to put 360. And for theta step, I want you to put 5. And then for x, and I'm not going to write this every time, so please be paying attention. Because this is what we're going to use in our graphing. Oh, wait a minute. Now, I may have you change these numbers from time to time. And then I want your y's set up the same as your x's. So in window, it has you fill in a bunch of stuff. This is how I want you to fill in. Theta min 0, theta max 360, theta step 5. And then this time, and we'll be adjusting these maybe, but x-min is -5. That's a -5. X-max is 5 and x-scale is 1. And do the y's the same way. Have the y's set up exactly the same way. And we're going to talk about how I know this in a little bit. But right now, this is how you're setting this up. Okay. Now, I want you to go to y equals, the button right here that says y equals. And now notice it doesn't say y equals anymore. It says r equals, because that's the equation that we're going to put in. So we're going to type 2 cosine 3, and then theta is your variable button. Your variable button right here. That's what we used before to put x in. Now when you press it, it comes up theta. And then hit graph. Hit graph. And what you should see is something that looks like that. So if that's not what you got, I want you to rewind the video, go back and press in exactly what I told you to press, because that is what you should come up with. Now, on your notes, I want you to go ahead and sketch that roughly. It doesn't have to be perfect, but a rough sketch of that. And then next to it, I want you to indicate that this is a rose. This shape is called a rose. Oh, shoot. I graphed that wrong. Let me fix that real quick. That's what it looks like. I'm sorry about that. This is a rose. It has 3 leaves or petals. You can call these whatever you want. And the petals are 2 units long. So this number right here tells you how long the leaves are. This number right here impacts the number of leaves, but we got to do a couple more examples before we make any general statements. But this guy, the leaves are 2 units long, and there are 3 of them. That's what happened when I pressed graph on my calculator. That's what I got. You are not going to have to graph this by hand. You're going to have your calculator, so you just type in the equation, and the picture will come out. But this is a rose. It has 3 leaves or 3 petals, and each of the leaves is 2 units long. Okay, so now we're going to look at the next one. The next equation, B, says r equals 4 cosine 2 theta. Okay? So we're going to leave everything the same. We're not changing anything in our calculator at all. We're going to go to y equals. We're going to clear that equation that we just did. So hit clear. And then just put in 4 cosine 2 theta. Remember, theta is the variable button right next to alpha, right under mode. Press graph. And this time, you got a picture that looked like this. Those leaves are 4 units long. So this is another rose. There are 4 leaves, and they're 4 units long. Now remember, I told you that this number right here, back when we learned how to graph sines and cosines, this was the amplitude number. Told us how high the waves were. Now it tells us how long the leaves are. So this always tells me the length of the leaves. The length of the leaves. Now this number is significant, but we haven't quite figured out what's significant about it yet. We're just making some observations, and then we'll come back and talk about that number. But when you hit graph, when you put in that equation and hit graph, this is what you should get. All right. You're making these notes on your paper because we're going to have to make an observation here shortly. C is R equals 3 cosine 4 theta. So again, we don't have to change a thing on our calculator. We're just going to go to y equals, clear the last equation, and type in 3 cosine 4 theta. And hit graph. Those leaves are 3 units long. And how many are there? This is another rose. These are all roses. This one has 8 leaves, and they're 3 units long. So again, please, please, please be taking some notes here, because we got to make an observation about what is going on here. This number always tells me how long the leaves are. So you can see on your graph, look on your calculator, they're going out 3 units. It's kind of hard to tell on these diagonal ones, but you can certainly tell here. You can actually see the hash marks on your calculator. It's going out 3 units. And there's 8 of them. Wow. Okay. Last one. This is also a rose. These are all roses in this section. So maybe number 5, you just label rose, because all of these are roses. My grid's getting kind of messed up here, but you get the idea. All right, let's graph it. So I go to y equals, clear out the old one, and type 5 sine 5 theta. And hit graph. Now these leaves are 5 units long, which you knew that would happen. Hopefully you knew when you wrote the equation that these leaves were going to be 5 units long. And how many of them are there? There are 5 leaves, and they're 5 units long. Now, there is not ever going to be any confusion. This number right here, look where I'm pointing. This number right here tells you how long the leaves are. No confusion. That's how long the leaves are. How many leaves are there, though? Okay, so now we need to go back. I want to go back and look at all of the equations that we have graphed in this section. We did 2 cosine 3 theta. And it had 3 leaves. We did 4 cosine 2 theta, and it had 4 leaves. We did 3 cosine 4 theta, and it had 8 leaves. And then we did this one, and it had 5 leaves. So can you see a pattern? And remember, you're not looking at this number. This number tells you how long the leaves are. We are looking at this number right here to help us predict how many leaves there are. Would you notice something? If the number is odd, 5 theta, 3 theta, that's how many leaves you have. If the number is even, 4 theta, 2 theta, you have twice that many. So if this is an odd number, if the coefficient on theta is an odd number, that tells you exactly how many leaves you have. If it's an even number, you have double that. So let me give you just a couple of examples and make sure this is solidified in your head. These are not on the paper. So let's say we had 7 cosine 5, or let's use a number we haven't done yet. Let's do 6 theta. And then let's do 8 sine, and it doesn't matter if it's sine or cosine. Does not matter one bit. These are roses. And let's say 7 theta. Okay? So if I ask you to describe this equation without graphing it, you could tell me this is a rose. It has 12 leaves, and they are 7 units long. Because if this number is even, you have twice that many leaves, and this number always tells you how long they are. So this one would be a rose with 7 leaves, and they are 8 units long. So you need to make a note somewhere that this number right here always tells you the length of the leaves. Always, 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 always. That number is the length of the leaves. And this number tells you the number of leaves. Odd, same, even, double. So if it's an odd number, that's how many leaves you have. If it's an even number, you have double that many. So you want to make sure that you have that written down somewhere. And guess what? That's it for today. Have a good day.